Welcome, y'all. Back to some more geometry fun. I'm talking about inscribed angles. Now, very first section, we talked about inscribed, meaning it's drawn inside. Well, inscribed angles is just that. Angles that exist inside the circle where the vertex is on the circle. There. And then the parts of the angles are inside. So angle there and angle there. So inscribed angles is the legs, the vertex, and the legs. This is the angle we're talking about. It's drawn inside the circle. Intercepted arcs are the arcs that now happen because that. So when we drew this angle, we made an endpoint right there and right there. So this is the arc of that inscribed angle. Doesn't mean they're the same. No. But it means this is the intercepted arc. So if you see that, it's bound between the two legs. So here, and point there, and point there. This is the intercepted arc of this angle right there. All right. Now, this kind of goes to the theorem. Inscribed angle theorem says that the measure of the angle. So, for example, here's an inscribed angle because the vertex is on the circle. The measure of that angle is equal to 1/2 the measure of its intercepted arc. So this is the arc of this angle right here. This is the arc from here all the way to here. I wonder if you guys can hear me get so loud. To here. This is the arc of this inscribed angle right here. So the measurement of angle 1 is equal to 1/2 of arc AB. So take AB divided by half. Now, let's figure out what that actually is. So here, the time is 62. This is a central angle. Remember, the angle exists at the center, central angle. So that means this arc right here is 62. Angle 1 is equal to half of that. So we'll say, hey, the measurement of angle 1 is equal to the degrees of arc AB, which is 62, divided by 2. It gives us 31 degrees. The measurement of angle 1 is 31. So it's always going to be half of the arc. Central angles are the same. Inscribed angles are half. Kind of practice that a little more in a bit. Now, another thing. If two inscribed angles intercept the same arc, then those two angles are the same. So, for example, here, angle 1, if we follow its legs, we have an interception there. Follow the other leg there. So this is the arc of that angle. Here. Oh, sorry. Stay on the curve. There we go. It's a horrible curve, my bad. Let's look at angle 3 right here. Angle 3, follow this leg, goes there, and then follow the other leg to there. So from leg to leg, this is the arc of that. And let's look at angle 2. Angle 2, right, here's the angle, follow its leg, here's the end point. Follow the other one, here's the other end point. So this is the arc. So all three of these angles, inscribed angles, share the same arc. That means all three of these angles have the same value, which is half of that. So the measurement of angle 1 is equal to the measurement of angle 2, which equals the measurement of angle 3, which ultimately is the arc divided by 2. 64 degrees. All three of these are 64. 64. 64. That being said, let's kind of look at this. We want to find ultimately the value of angle R. Now we do know that this represents R, this represents S. Now what they both share in common is that the arc of angle R right here goes from U to T. The arc of angle S right here goes from U to T. They share the same arc. That means they are equal to each other. That means their equations equal each other. So we can say 12x minus 13 equals 9x plus 2. So let's solve for x. So we'll subtract 9x minus 9x and then plus 13 plus 13. So 12 minus 9 gives us 3x. 2 plus 13 equals 15. Divided by 3, you get x equals 5. But that's not the answer. The question is find the measurement of angle R. So we're going to plug in that 5 back in here. So we got 12 times 5 minus 13. 12 times 5 gives us 60. Minus 13 gives us 50, 47 degrees. So this is 47. So is angle S 47 degrees. All right. Good job, y'all. Next theorem. states that an angle inscribed inside a semicircle is always 90, a right angle, which is 90 degrees, which makes sense. Look at all three of these angles. This angle right here, this angle right here, and this angle right here. They all have the same endpoints, there to there. Now, for the red one, its arc goes from here all the way around this way to here. But for the blue one, it goes from here. Its endpoints go over there, follow the other leg, there. It's this semicircle here. They're still semicircles regardless. Same thing with the green one right here. Endpoint right there, endpoint right there, goes around this way. This is a semicircle. So, as we said, inscribed angles always half that. So this is 180. That makes this 90. This is 180. Makes that 90. And if this is 180, makes this 90 degrees. They're always half of that. Let's talk about this here. So a quadrilateral, it is inscribed in a circle. So we drew a quadrilateral inside a circle. Opposite angles are always supplementary. So it means this angle plus this angle always equals 180. And so, and vice versa. This angle over here plus this angle over here equal 180 together. And let's see why. So let's kind of use this as an example. So let's say this angle right here. Let's look at the arc of this right here. We don't know what this is, but here's the angle. The arc goes from here all the way around to its other endpoint right here. And let's look at the other angle. So this angle right here, the arc goes from here to here, but it goes around this way. Wow, that's a horrible, sorry. If I put these two arcs together, that makes 360. And if both of these are half of their opposite angles, that means together they're half of 360, which is 180. Supplementary, 180. So that being said, let's find the measurement of angle Y, angle X, knowing that these angle is 110 or 180. Now remember, these two are supplementary to each other. That means X plus 110 equals 180. And then these two are supplementary to each other, meaning Y plus 85 equals 180. So here we subtract 85 minus 85. We end up getting Y equals 95. Easy enough. Let's look at this one. Subtract 110 minus 110. X equals, what is that, 70? Yeah, 70. So this is 70. This is 95. But what about, let's get a little bit fancy, what about the arc of X? The arc of X will go, follow the legs, endpoint there and endpoint there, from here all the way to here. If the angle is 70, what is the arc? It's double. So as we're used to going, the angle is half of the arc, well, the arc is double the angle. This is 140 degrees right here, from here all the way to here. You'll be asked that throughout the whole one. Oh, for example, here's a perfect example here. You gotta find X, Y, and Z. X, Y, and Z. Now, they tell us this is 150. Now, by itself, that doesn't help us. This is Z. By itself, it kind of does. So let's look at this. This is 40. We don't know if those are equals, and we can't say, so we can't say they're equal to each other. But we do know that this is 40, this is X, and this is Y. I'm going to do different arcs, but they're a little different. There's three different angles. So let's start with Y. Y actually be the easiest. So let's follow the endpoints of Y. So the endpoints of angle Y goes from there all the way there. That means the arc of angle Y goes from here to here, making that's the 150. That 150 is very important. That's the intercepted arc of this inscribed angle right here. So if this is 150, that makes Y 75, half of that. So look at Z over here. Z is talking about this arc. I'm going to do this in a different color. Z is this arc that goes from here all the way around to here. Well, we follow these legs, that leads the boat to this angle over here. So if that's 40, this is double that, making this 80. Now, we got to find this last one. Now, we could add those to subtract from 180, but we could also say, hey, these three angles together in a triangle equal 180. So we could say 40 plus 75 plus angle X equals 180. Yeah, so let's add those two up. We get 115 equals plus x equals 180. We subtract 115 both sides. You're getting x equals 5, 7, 65 degrees. This is 65 degrees right there. All right, y'all. That's it. Hopefully this helps out a little bit. Y'all have a wonderful day. Bye.